What if I told you that right now, at this very moment, the only reason you're experiencing time passing is because light is moving? And here's what will completely shatter everything you think you know about reality. If light stopped moving, time itself wouldn't just slow down or pause. It would cease to exist entirely. Not freeze, not pause, but actually end as a fundamental property of the universe. I know that sounds absolutely insane. You're probably thinking, wait, light is just light. It's what lets me see things. How could it possibly be connected to time itself? But here's the mind-blowing truth that physicists discovered over a century ago, and we're still trying to fully understand. Light and time aren't just connected. They're the same thing, woven together into the fabric of reality itself. And when you understand why this is true, everything you thought you knew about existence will never be the same. Think about this for a second. Right now, you're sitting there, watching this video, feeling time tick forward, second by second. But from the perspective of light itself, from the perspective of a photon traveling from the sun to your eye, no time passes at all. Zero. Zilch. From light's point of view, it's created and absorbed in the same instant, even if it travels for billions of years from our perspective. Light doesn't experience time. And here's the truly shocking part. Light is the speed limit of the universe, not because it's really fast, but because it's the speed at which time itself flows. Before we go any further, smash that like button and subscribe, because what you're about to learn in the next 3.5 hours will fundamentally change how you perceive reality. Seriously, I want you to comment below right now and tell me, what country are you watching from? And what time is it where you are? Because by the end of this video, you're going to understand why that question is far more complicated and weird than you ever imagined. Let's start with something that seems simple, but will lead us down the rabbit hole. You learned in school that light travels at 299,792,458 meters per second, about 186,000 miles per second. Fast, right? But here's what they didn't tell you. That number isn't just a speed. It's not like light is trying really hard to go fast, and that's the best it can do. No. The speed of light is the conversion factor between space and time. It's literally the exchange rate between distance and duration. Imagine you have two currencies, meters and seconds. The speed of light is the exchange rate that tells you how many meters equal 1 second in the universe's accounting system. When we say light travels at 299,792,458 meters per second, what we're really saying is that 299,792,458 meters of space is 1 second of time, just measured in different units. They're not separate things, they're the same thing viewed from different angles. Now, here's where it gets weird. Albert Einstein, yes, that Einstein, the guy with the crazy hair from all the posters, discovered something in 1905 that broke physics. He published a paper called On the Electrodynamics of Moving Bodies in September of 1905, and buried in the mathematics was a truth so disturbing that even Einstein himself struggled with its implications for years. He discovered that space and time aren't fixed, absolute things. They bend, stretch, and compress depending on how fast you're moving. But the one thing that never changes, no matter how fast you're going, no matter where you are in the universe, no matter what you're doing, the speed of light is always exactly the same. Always 299,792,458 meters per second. Always. Think of it like this. Imagine you're on a train going 60 miles per hour, and you throw a ball forward at 30 miles per hour. To someone standing on the ground watching, that ball is moving at 90 miles per hour, right? The speeds add up. Simple addition. But light doesn't work that way. If you're on a spaceship going 99% the speed of light, and you shine a flashlight forward, the light doesn't go 199% the speed of light. It goes exactly the speed of light. And to make that mathematically possible, time itself has to slow down for you. and space has to compress. The universe literally warps reality to keep light at the same speed. This isn't speculation. This isn't philosophical mumbo-jumbo. This has been tested thousands of times. GPS satellites orbiting Earth right now have to account for the fact that time runs slightly faster for them than it does for you on the ground, because they're moving faster and they're in a weaker gravitational field. If we didn't adjust for this time dilation, this stretching of time, your GPS would be off by miles within just a few hours. So when we ask, could time end if light stopped? We're not asking a simple question. We're asking, what happens to the fundamental fabric of reality if the one constant that holds everything together suddenly changes? Here's your first mind-blown moment. Light doesn't just illuminate reality. Light is the structure of reality. It's the skeleton that everything else hangs on. And if that skeleton disappeared, but we're getting ahead of ourselves. To understand what would happen if light stopped, we first need to understand what light actually is. And trust me, it's so much stranger than you think. Most people think light is a wave, like a ripple in water. And that's true. But it's also a particle, like a tiny bullet. How can something be both a wave and a particle at the same time? How can light be in two contradictory states simultaneously? Here's where we meet our first scientist who completely revolutionized our understanding, Max Planck. In December 1900, Planck was trying to solve what seemed like a simple problem about how hot objects glow. But to make his equations work, he had to propose something radical. Energy doesn't come in smooth, continuous amounts. It comes in tiny, discrete packets quanta. Light isn't a continuous wave. It's made of individual particles called photons. This discovery, announced in his paper on the theory of the energy distribution law of the normal spectrum, literally created quantum mechanics. And Planck himself was so disturbed by what he'd found that he spent years trying to disprove his own theory. He called it an act of desperation because it violated everything physicists knew about reality. Then came Albert Einstein again, who in that same miracle year of 1905 published another paper explaining the photoelectric effect, why light hitting metal produces electricity. He proved that light really does come in particle packets, in photons. He literally won his Nobel Prize for this, not for relativity. But wait, if light is made of particles, how can it also be a wave? This is where things get truly bizarre. Thomas Young performed an experiment in 1801 called the double-slit experiment. He shot light through two narrow slits and watched what pattern it made on a screen behind them. If light was particles, you'd expect two bright lines. But that's not what happened. Instead, he got an interference pattern alternating light and dark bands, exactly what you'd get if two waves were overlapping and canceling each other out. Okay, so light is a wave. Mystery solved, right? Wrong. In the 1920s, scientists repeated Young's experiment, but with a twist. They sent photons through one at a time. Single particles. And here's what will melt your brain. Even when photons went through one at a time, with sometimes hours between them, the interference pattern still built up over time. Each individual particle somehow interfered with itself, as if it went through both slits simultaneously. How is that possible? How can one particle be in two places at once? The answer is quantum superposition. Until observed, the photon exists in a superposition of all possible states. It literally goes through both slits at the same time. It's not that we don't know which slit it went through. It's that it didn't go through one or the other. It went through both. Reality itself is in multiple states simultaneously until something observes it. And here's the kicker. When scientists set up detectors to watch which slit the photon went through, the interference pattern disappeared. The moment you observe the photon, it chooses one path, and the wave behavior vanishes. The act of measurement collapses the superposition and forces reality to pick a single outcome. Think of it like this. Imagine you have a coin spinning in the air. While it's spinning, it's not heads or tails, it's both simultaneously. Only when it lands does it become one or the other. Except with quantum mechanics, the coin literally is both heads and tails while spinning. It exists in a genuine superposition of both states. This is the nature of light. This is the nature of reality at its most fundamental level. Now remember, we're building toward understanding what happens if light stops. So keep this in mind. Light is quantum. It exists in superposition. It's both wave and particle. And this quantum weirdness is absolutely crucial to why light is connected to time. Let me introduce you to another scientist, Niels Bohr, who worked with Einstein and argued with him constantly about quantum mechanics. Einstein famously said, "God does not play dice with the universe," complaining about quantum randomness. Bohr supposedly replied, "Einstein, stop telling God what to do." Their debates in the 1920s and 1930s shaped modern physics. And here's what Bohr realized. We can't separate the observer from what's being observed. Reality doesn't exist independently out there, waiting to be discovered. The act of observation creates reality. If that sounds insane, good. It should, because it is insane. But it's also experimentally verified thousands of times over. So let's connect this back to our question. If light is quantum, if it exists in superposition, if it creates reality through observation, what happens if it stops? Before we answer that, I need you to understand something even more fundamental. We need to talk about what time actually is. You experience time as this flowing thing, like a river carrying you from past to present to future. But here's what physics tells us, that flow is an illusion. Time doesn't flow. There is no universal now that sweeps across the universe like the hand of a clock. Einstein proved this with special relativity. Two events that are simultaneous for you might happen at different times for someone moving relative to you. There's no universal agreement on what now means. Your present moment is different from my present moment if we're moving relative to each other. Think of it like this. Imagine you're on a train and someone on the platform is watching you go by. You both have clocks. You both see time passing. But when you compare notes later, you'll find that less time passed for you than for them. This isn't because the clocks are broken. This is because time itself literally passed more slowly for you. This effect gets more extreme the faster you go. If you got on a spaceship and accelerated to 99.9% the speed of light, then flew around for what felt like 1 year to you, when you came back to Earth, decades might have passed. Your twin brother would be an old man while you barely aged. This is the famous twin paradox. Except it's not a paradox, it's reality. Time dilation has been tested with atomic clocks on airplanes. Physicist Joseph Haffel and astronomer Richard Keating did this exact experiment in 1971. They flew atomic clocks around the world and compared them to identical clocks that stayed on the ground. The flying clock showed less time had passed exactly the amount predicted by Einstein's equations, accurate to within nanoseconds. So time isn't universal. Time isn't constant. Time is relative. But here's the truly mind-bending part. From the perspective of light itself, time doesn't exist at all. Do the math with me here. Einstein's time dilation equation says that time slows down the faster you go. At 50% the speed of light, time runs at about 87% normal speed. At 90% the speed of light, time runs at about 44% normal speed. At 99% the speed of light, time runs at about 14% normal speed. What happens when you reach 100% the speed of light? Time dilation becomes infinite. Time stops completely. This means that for a photon, a particle of light traveling from a distant star to your eyeball, no time passes at all. Even if that journey takes millions of years from our perspective, from the photon's perspective, it's instantaneous. The photon is created and absorbed in the same moment. Light doesn't experience time. Light exists outside of time. Let that sink in. The thing that lets you see, the thing that warms your skin, the thing that makes life on Earth possible, it exists in a timeless state. Now we're ready for the second mind-blown moment. Time only exists because we move slower than light. If we could move at the speed of light, we'd experience the entire history of the universe as one eternal moment. Past, present, and future would all exist simultaneously. There would be no flow, no change, no causation. Just one infinite, timeless now. Time, as we experience it, is a consequence of being stuck moving slower than light. We're trapped in time because we can't reach light speed. And here's the absolutely critical point. Light speed isn't just fast. It's the cosmic speed limit, because it's the boundary between time and timelessness. It's the edge of causality itself. So when we ask, what happens if light stops? We're really asking, what happens if the boundary between time and timelessness changes? Before we dive into that apocalyptic scenario, let me ask you something. Are you still with me? If your mind is already blown, and we're only 25 minutes in, leave a comment and let me know. Write timeless if you're following along, because we're about to go even deeper. Let's talk about what light actually does in the universe. Light isn't just passive illumination. Light is the messenger that carries information about causality. Let me explain what I mean. When you see something happen, a car crash, a lightning strike, someone waving at you, you're not seeing it happen in real time. You're seeing it happen in the past. Light has to travel from the event to your eye, and that takes time. When you look at the sun, you're seeing it as it was 8 minutes ago, because that's how long it takes light to travel from the ants, sun to Earth. When you look at the nearest star beyond the sun, Proxima Centauri, you're seeing it as it was 4.2 years ago. When you look at distant galaxies, you're seeing them as they were billions of years ago. Some of those galaxies might not even exist anymore, but their light is still traveling through space, carrying information about their past existence. This is crucial. Light is how the universe communicates cause and effect. When something happens over here, light carries that information over there. Without light, or more precisely without anything moving at light speed, because other massless particles like gluons also travel at light speed, there would be no way for different parts of the universe to influence each other. Here's an analogy. Think of the universe like a vast room full of people. Light is like sound waves that let people talk to each other. If sound stopped working, everyone would be isolated, unable to communicate, unable to coordinate. The room would still exist, the people would still exist, but they'd be fundamentally disconnected from each other. Except with light and the universe, it's even more extreme, because light doesn't just carry information. It is the structure that connects space-time itself. Let me introduce you to Hermann Minkowski, one of Einstein's former mathematics professors. In 1908, Minkowski gave a lecture where he made a statement that sounds almost religious in its profundity. Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. He formalized Einstein's relativity into what we now call Minkowski spacetime, a four-dimensional structure where space and time are unified into a single entity. Not space plus time, spacetime, one thing. In this framework, the speed of light is the conversion factor between the space dimensions and the time dimension. It's literally the Rosetta Stone that translates between spatial distance and temporal duration. Imagine a graph where the x-axis is space and the y-axis is time. Light traces out lines at 45-degree angles on this graph because it travels 1 unit of space for every unit of time when using units where the speed of light equals 1. These 45-degree lines are called light cones, and they define the absolute limits of cause and effect. Anything inside your past light cone could have affected you. Anything outside your past light cone is too far away for its influence to have reached you yet. Anything inside your future light cone can potentially be affected by you. Anything outside your future light cone is forever beyond your reach. These light cones define the structure of causality itself. They define what can influence what can know about what can interact with what. Now here's the third mind-blown moment. If light stopped, these light cones would collapse. Causality would end. Not just time, cause, and effect itself would cease to exist. Without light-speed interactions, there would be no way for one event to lead to another. The universe wouldn't freeze like a paused video. It would fragment into infinite isolated points of spacetime, each completely disconnected from all the others. Reality would shatter into uncountable pieces with no relationship to each other whatsoever. Does that sound like the end of time to you? Because it should. Time isn't just about clocks ticking. Time is about causality, about one moment leading to the next, about the past influencing the future. Without that causal connection, without light to mediate those connections, there is no time. But we're still building the foundation. We need to go deeper still. Let's talk about what light is made of at the most fundamental level, because this will become crucial when we discuss what happens if it stops. Light is electromagnetic radiation. That means it's a self-propagating wave of electric and magnetic fields. Here's how it works. An oscillating electric field creates a magnetic field. That oscillating magnetic field creates an electric field. That electric field creates another magnetic field. And so on, forever, each field sustaining the other, propagating through space at, you guessed it, the speed of light. James Clerk Maxwell figured this out in the 1860s. He unified electricity and magnetism into a single theory described by 4 elegant equations, Maxwell's equations. When he solved these equations to see how electromagnetic fields would behave, he discovered they produced waves that traveled at a specific speed. He calculated that speed, and it was 299,792,458 meters per second, the speed of light. Maxwell realized that light itself is electromagnetic waves. This discovery, published in his 1865 paper, A Dynamical Theory of the Electromagnetic Field, is one of the greatest scientific achievements in human history. He literally discovered what light is. But here's what's really strange. Maxwell's equations don't care about your reference frame. They work the same whether you're stationary or moving. This was weird, because back then, scientists thought there must be some medium, the luminiferous ether, that light waves traveled through, like sound waves travel through air. If that were true, you should be able to measure your speed relative to the ether. If you're moving through it, light should appear to go slower in the direction you're moving and faster in the opposite direction. In 1887, physicists Albert Michelson and Edward Morley performed an incredibly precise experiment to detect this effect. They built an interferometer that could detect even tiny differences in the speed of light in different directions. They found nothing, zero difference. Light traveled at exactly the same speed in all directions, regardless of how the Earth was moving through space. This null result confused everyone. How could light always go the same speed? It violated common sense. It violated Galilean relativity. It broke physics. Until Einstein came along and said, what if the speed of light is constant and space and time change instead? That was the insight. That was the revolution. Space and time aren't fixed backgrounds where events happen. They're dynamic, flexible things that adjust to keep light speed constant. Think of it like this. Imagine you're trying to measure how fast a fish swims through water, but the water itself is flowing at different speeds in different places, and the flow rate changes depending on how fast you're moving. Measuring the fish's speed becomes meaningless because the medium keeps changing. Now imagine instead that the fish always swims at exactly the same speed no matter what, and the water adjusts its flow to make that possible. That's what space-time does for light. This is why light speed is absolute. It's not a speed in the conventional sense. It's the structure of spacetime itself. So when we ask what happens if light stops, we're asking, what happens if the structure of spacetime changes? What happens if the fundamental constants of reality shift? We're 45 minutes in, and I want you to pause and think about something. Everything you've learned so far, relativity, quantum mechanics, the nature of light, the structure of spacetime, all of it is established, experimentally verified science. This isn't speculation. This is reality as we understand it. And all of it points to the same conclusion. Light and time are inseparable. They're two aspects of the same underlying structure. Now let's start exploring what happens if that structure breaks. To understand the consequences of light stopping, we need to understand what keeps light moving in the first place. Why does light travel at all? This gets into quantum field theory, which is the deepest level of reality we currently understand. According to quantum field theory, all of space is filled with quantum fields. These aren't fields in the classical sense, like magnetic fields. They're probability fields that permeate all of existence. Every particle is actually an excitation or ripple in its corresponding field. Electrons are ripples in the electron field. Quarks are ripples in the quark field. And photons, particles of light, are ripples in the electromagnetic field. These fields are always there, everywhere, even in empty vacuum. The vacuum isn't empty. It's seething with quantum fields in their lowest energy state. Paul Dirac, one of the founding fathers of quantum mechanics, predicted in 1927 that even the vacuum has energy. He called it zero-point energy, and he predicted that this vacuum energy would produce weird effects. In 1948, Dutch physicist Hendrik Casimir predicted one such effect. If you put two metal plates very close together in a vacuum, the quantum fields between them would be constrained, and this would create a tiny attractive force between the plates. In 1997, physicist Steve Lamoureux measured this Casimir effect with high precision, confirming it was real. The vacuum isn't nothing. It's something. It's a quantum foam of virtual particles, constantly popping into and out of existence. And light? Light is a particular kind of vibration in the electromagnetic field that propagates through this quantum foam at the maximum speed allowed by the structure of spacetime. So for light to stop, one of several things would have to happen. First possibility, the electromagnetic field itself would have to disappear. But the electromagnetic field is one of the fundamental fields of nature. It's not something that can just turn off. It's woven into the structure of reality. Asking for the electromagnetic field to disappear is like asking for space itself to disappear. Second possibility, the quantum fluctuations that allow field excitations would have to stop. But these fluctuations are a consequence of the Heisenberg uncertainty principle, which is a fundamental law of quantum mechanics. Werner Heisenberg discovered in 1927 that you can't know both the position and momentum of a particle with perfect precision. This isn't because our instruments aren't good enough. It's because reality itself is fundamentally uncertain at the quantum level. This uncertainty means that quantum fields must fluctuate. A perfectly still, static field would violate the uncertainty principle. So quantum fluctuations can't stop without breaking quantum mechanics. Third possibility, the speed of light itself, the cosmic speed limit, could change. But as we've discussed, the speed of light isn't just a speed. It's the structure of spacetime. Changing it would mean changing the fundamental geometry of reality. So here's the fourth mind-blown moment. Light can't stop without breaking the laws of physics themselves. For light to stop, reality as we know, it would have to fundamentally restructure. But let's imagine it anyway. Let's do the thought experiment. What if, somehow, impossibly, light stopped moving? First, let's be clear about what we mean. Do we mean photons stop moving, but still exist? Or do we mean the electromagnetic field itself ceases to vibrate? Or do we mean the speed of light, the cosmic speed limit, drops to zero? Each scenario has different implications, but all of them are catastrophic. Let's start with the simplest interpretation. Photons stop moving, but the electromagnetic field still exists. Immediate consequence: you go blind. Not just you, everything goes blind. No light enters your eyes. No light reflects off objects. The world doesn't go dark in the sense of being dimly lit. It goes absolutely, perfectly, incomprehensibly black, because there's no light at all reaching you. But it's worse than that. The electricity in your brain is mediated by electromagnetic forces. Nerve signals are electrical impulses. If electromagnetic interactions stopped propagating, your neurons would stop firing. Your brain would cease to function. You'd be dead before you even realized what happened. Actually, you'd be less than dead. You'd cease to exist in any meaningful sense, because atoms themselves are held together by electromagnetic forces. The electrons orbiting your atomic nuclei are bound by electromagnetic attraction. If that force stopped propagating, atoms would fall apart. Within a fraction of a second, all matter in the universe would disintegrate into a plasma of unbound particles. But wait, it gets even worse. Remember, light doesn't just mean visible light. The electromagnetic spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. All of these are electromagnetic radiation, just at different frequencies. If light stops, all electromagnetic radiation stops. That means the heat radiation from the sun stops. The radio waves carrying communication stop. The X-rays from distant cosmic events stop. The cosmic microwave background radiation, the afterglow of the Big Bang itself, stops. The universe doesn't freeze. It's not like everything gets very cold. Temperature itself is a measure of how fast particles are moving and vibrating. But heat transfer happens through electromagnetic radiation. If that stops, there's no way for heat to flow from hot areas to cold areas. Everything would be thermally isolated. Each particle would retain its kinetic energy with no way to transfer it to other particles via radiation. The concept of thermal equilibrium would cease to exist. But I said it gets worse, and I meant it. We're still thinking too small. If the speed of light, the cosmic speed limit, dropped to zero, that would mean changing the fundamental constant c in Einstein's equations. And c appears everywhere in physics, not just in equations about light. The most famous equation in physics is E equals mc, energy equals mass times the speed of light squared. This equation tells us that mass and energy are equivalent, and the conversion factor between them is c squared. If c went to zero, what happens to this equation? E equals m times 0 squared. E equals 0. All energy in the universe would vanish. Not just become unavailable, actually cease to exist. Mass itself, according to Einstein, is a form of energy. The particles that make up your body have mass energy. If c goes to 0, that mass energy would, what? Disappear? Transform into something else? The equations break down? The math doesn't work. This is the fifth mind-blown moment. The speed of light is so fundamental to the structure of reality that changing it would cause existence itself to become mathematically undefined. But let's think about this from a time perspective, which is what we're really interested in. If light stopped, or if the speed of light went to 0, time dilation would reverse. Remember, time slows down the faster you go, approaching 0 as you approach light speed. If light speed itself were 0, the time dilation equation would flip. Time would become infinite, or undefined, or cease to have meaning. The concept of before and after requires causality. It requires one event to influence another. And influence, any form of interaction, propagates at light speed. If light speed is 0, influences can't propagate. Cause and effect would end. Without causality, there is no time, not frozen time, not stopped time, no time at all. The concept becomes meaningless. It would be like asking what's north of the North Pole. The question assumes a framework directions. Geography, that doesn't apply. Similarly, asking what happens after light stops assumes a temporal framework that would no longer exist. You might be thinking, okay, but this is all theoretical. This can't actually happen, right? And you'd be correct. Under the laws of physics as we understand them, the speed of light can't change. It's a fundamental constant. It's built into the structure of spacetime itself. But here's where things get interesting. We're going to talk about scenarios where the laws of physics themselves might change. Have you ever wondered why the laws of physics are the way they are? One possibility, a phase transition in the vacuum itself. Remember how we talked about quantum fields filling all of space? These fields exist in different energy states. The state they're in determines the properties of particles and forces. Imagine the field is like water. Water can exist as ice, liquid, or steam, different phases of the same substance. The universe might undergo phase transitions where the quantum fields shift from one state to another. And here's the terrifying part. We might be in a metastable state. That means our current vacuum state seems stable, but there might be a lower energy state available. And if the vacuum transitioned to that lower state, the fundamental constants would change instantly. Physicist Sidney Coleman worked this out mathematically in 1977. He described how a bubble of true vacuum could form and then expand at light speed, converting everything it touches to the new vacuum state with new physical laws. This is called vacuum decay, and it's a legitimate possibility according to our understanding of quantum field theory. We don't know if our vacuum is stable, metastable, or unstable. Measurements of the Higgs boson mass suggest we might be metastable, right on the edge. If vacuum decay happened, a bubble of new physics would spread out at the speed of light, and there would be no warning. We wouldn't see it coming because it propagates at light speed, the same speed at which we receive information. The wall of changed physics would arrive at the exact same moment as the light carrying information about it. One moment, you'd be sitting there. The next moment, the fundamental constants governing your atoms would change, and well, we don't know. You'd probably disintegrate, or transform into something unrecognizable, or cease to exist entirely. And here's the connection. If such a phase transition changed the speed of light to zero, time would end. Not just for you, for the entire universe. In an instant. This is the sixth mind-blown moment. The universe might be fundamentally unstable, and at any moment, reality itself could restructure in a way that ends time. Now, before you panic, let me stress, this is extremely unlikely. If it were likely, it probably would have happened already in the 13.8 billion years the universe has existed. The fact that we're still here suggests the vacuum is either stable or that the probability of decay is incredibly low. But incredibly low isn't zero. All right, we're about 75 minutes in, and I hope you're still with me because we're about to shift gears. We've built the foundation. We understand what light is, what time is, how they're connected, and what catastrophic scenarios could cause light to stop. Now let's get personal. Let's talk about how all of this relates to you, your life, your experience of reality right now. Because here's the thing. Even though light stopping is essentially impossible, understanding this connection between light and time reveals something profound about the nature of your existence. You are right now, at this very moment, a time-traveling being. You're moving through time at 1 second per second, traveling from the past toward the future, unable to stop, unable to reverse course, unable to even slow down. But that journey through time, that experience of present moment after present moment, is only possible because you're moving slower than light. Think about it. You're on Earth, which is rotating at about 1,000 miles per hour at the equator. Earth is orbiting the Sun at about 67,000 miles per hour. The Sun is orbiting the center of the galaxy at about 514,000 miles per hour. The galaxy itself is moving through space at about 1.3 million miles per hour. You are in motion. Constant, rapid motion through space. And that motion through space determines your speed through time. In fact, physicist Brian Greene points out something remarkable. Everything in the universe is always moving through space-time at exactly the speed of light. Always. The combination of your motion through space and your motion through time always adds up to light speed. When you're sitting still in space, all of your motion is through time. You're moving through time at the maximum rate. But when you start moving through space, some of that motion through time converts to motion through space. You move through time more slowly. This is why time dilation happens. You have a fixed speed through space-time. The more of that speed you use to move through space, the less is available for moving through time. Imagine you're in a car that can only go 60 miles per hour total. If you're going north at 60 miles per hour, you're going 0 mph east. If you want to go east, you have to angle southeast, which means going slower northward. The total speed stays at 60, but how it's distributed between north and east changes. That's what you're doing through space-time. You're always moving at light speed through the combined space-time dimensions. How that motion is distributed between spatial movement and temporal movement changes, but the total is constant. This means time isn't something that happens to you. Time is something you're doing. You're traveling through time right now by virtue of existing. And light? Light is moving through space at maximum speed, which means it has zero speed left over for moving through time. That's why photons don't experience time. They've used up all their space-time motion budget on spatial movement. This should blow your mind because it means you are controlling your speed through time right now. The more you move through space, the slower you move through time. If you stood up right now and started running, you would age slightly slower than if you stayed sitting. The difference would be unimaginably tiny nanoseconds over your entire lifetime. But it's real. Olympic sprinter Usain Bolt, over his entire career of running at high speeds, aged about 0.00001 seconds less than he would have he'd been stationary. GPS satellites orbit Earth at about 14,000 kilometers per hour, and they age about 7 microseconds per day slower than clocks on Earth's surface due to this effect. They also age faster due to being in weaker gravity, and that effect is larger, but that's a different phenomenon. You are a time traveler. You're just moving through time very, very slowly relative to light. But here's what makes this personal. Your experience of time, your consciousness, your perception of moments flowing from past to future is created by your motion through time. Philosopher and physicist Carlo Rovelli argues in his book, The Order of Time, that time as we experience it is an emergent property, a consequence of our perspective as beings made of entropy-increasing matter moving slower than light. From the universe's perspective, from the perspective of the fundamental laws of physics, there is no flow of time. There's no universal now. There's no objective present moment. The past, present, and future all exist equally. They're just different regions of space-time. This is called the block universe view of time, and it's a direct consequence of relativity. Einstein himself wrote, when his friend Michel Besso died, "Now he has departed from this strange world a little ahead of me. That means nothing." People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. If time's an illusion, if the flow of time is just a perspective effect, then what are you actually experiencing when you feel time passing? You're experiencing your consciousness moving along your world line, your path through space-time. Imagine space-time as a four-dimensional block with 3 spatial dimensions and 1 time dimension. Your entire life, from birth to death, is a thread running through this block. Your world line. Your consciousness, the thing that is you, reading these words right now, is a pattern of information moving along that world line. At each point along the line, you have memories of the past, earlier points on the world line, and anticipations of the future, later points. This creates the subjective experience of time flowing, but the entire world line exists all at once. Your entire life, every moment you've experienced and will experience, is already there in the block universe. This is the seventh mind-blown moment. From the universe's perspective, you're not moving through time. You already exist, complete, from birth to death. The flow of time is your subjective experience of existing as a pattern that has memories. Does this mean free will is an illusion? Does this mean the future is predetermined? These are deep philosophical questions that physicists and philosophers still debate. Compatibilists argue that free will can coexist with determinism. Others argue that quantum randomness introduces genuine unpredictability into the future. But here's what we can say for sure. Your experience of time is real to you. The choices you make feel real. The consequences matter. And whether or not the future is predetermined, you have no way of knowing what it is until you get there. You still have to live your life forward, moment by moment, making decisions. The block universe view doesn't make your life meaningless. It makes it eternal. Every moment you've experienced will always exist in space-time. Your first kiss, your proudest achievement, your deepest sorrow, they're not gone. They exist at their location in space-time forever. You're not just a temporary pattern that will dissolve into nothingness. You're a permanent structure in the fabric of reality itself. And this is where the connection to light becomes profound. Light connects these moments. Light carries causality from one event to another. Light is the medium through which meaning flows through space-time. When someone you love smiles at you, photons bounce off their face, carrying information about their expression, and enter your eye. Those photons create chemical reactions in your retina that send electrical signals to your brain that create a memory. That memory is a pattern of neural connections that persists. Light created that memory. Light connected that moment of their smile to all your future moments where you remember it. Light is the thread that weaves the tapestry of your life. It connects moments. It enables memory. It makes experience possible. And time? Time is the dimension along which these connections run. Time is the direction in which causes lead to effects, in which light propagates, in which consciousness experiences the unfolding of reality. So when we ask, could time end if light stopped? We're asking, could the threads that weave reality together unravel? And the answer, I hope you now understand, is yes. If light stopped, the causal structure of reality would collapse. Time wouldn't freeze it, would cease to be a coherent concept. But here's the beautiful part. Light isn't going to stop. The speed of light is woven into the deepest laws of physics. It's part of the structure of existence itself, which means time will continue. Causality will persist. The universe will keep evolving. In this scenario, time continues forever, but nothing interesting happens. The universe reaches maximum entropy, maximum disorder, and just exists, static, dead, timeless in the sense that nothing changes, even though time technically continues. Another possibility is the Big Rip. If dark energy, the mysterious force causing the universe's expansion to accelerate, grows stronger over time, it could eventually overcome all other forces. Galaxies would be torn apart, then solar systems, then planets, then atoms. The fabric of space-time itself would tear, and the universe would end in a singularity where physics breaks down. In this scenario, time ends because space-time itself is destroyed. A third possibility is the Big Crunch. If the universe has enough matter, gravity could eventually halt the expansion and reverse it. A universe would collapse back into a singularity, similar to the Big Bang, but in reverse. Time might end at that singularity, or according to some theories, bounce back in a new Big Bang, creating a cyclic universe. But here's what's fascinating. All of these scenarios assume the fundamental constants stay constant. If the speed of light could change, the fate of the universe could be completely different. Some cosmologists, like Joe Maguayo and John Barrow, have proposed theories where the speed of light was different in the early universe. This could solve certain cosmological puzzles, like the horizon problem. If the speed of light can vary, then time itself can flow at different rates in different epochs of the universe. The early universe might have experienced time very differently than we do now. In the far future? Who knows? Maybe as the universe expands and cools, the structure of spacetime changes. Maybe quantum fluctuations in the vacuum eventually trigger a phase transition and the laws of physics shift. We're living in a specific era of a specific phase of the universe's evolution. The rules we know might not be eternal. But again, these are speculations. Based on what we know now, the speed of light is constant. Time will continue, and the universe will keep evolving according to the laws of thermodynamics toward eventual heat death in trillions upon trillions of years. Long after Earth is gone, long after the sun has died, long after the last stars have burned out, time will continue, unless something breaks. Let's talk about black holes for a moment, because they're the most extreme environment in the known universe, and they do weird things to time. Near a black hole, the gravitational field is so strong that it warps space-time dramatically. Time dilation becomes extreme. If you watch someone fall toward a black hole's event horizon, you'd see them slow down, redshift, and appear to freeze right at the horizon, taking infinite time to cross it from your perspective. But from their perspective, they'd cross the horizon in finite time and continue falling toward the singularity at the center. At the singularity itself, space-time curvature becomes infinite. The equations of general relativity break down. We don't know what happens there. Time might end, or transform into something else, or loop back on itself. Physicist Kip Thorne, who won the Nobel Prize for his work on gravitational waves, has studied these extreme conditions extensively. He points out that at the singularity, our concepts of space and time cease to have meaning. The singularity is a place where physics ends. But here's the wild part. Quantum mechanics might save us. Stephen Hawking showed in 1974 that black holes aren't entirely black. They emit Hawking radiation due to quantum effects near the event horizon. Over enormous timescales, black holes evaporate. And when they evaporate completely, they disappear, taking their singularities with them. So maybe singularities are temporary. Maybe time doesn't truly end even there. Hawking also proposed, along with James Hartle, a model of the universe's origin called the no-boundary proposal. In this model, time itself emerges at the Big Bang. Before the Big Bang, there was no time. Not because time was frozen, but because before is meaningless. Time is a property of the universe that came into existence with the universe. If time had a beginning, could it have an end? Maybe. If the universe collapsed in a big crunch, time might run backward or end at the crunch singularity. Or if vacuum decay occurred, time might end when the bubble of new physics consumes everything. But these are enormous cosmic scale events. They're not things you need to worry about in your daily life. Let's bring this back to you, personally. You're going to die someday. That's certain. And when you die, your experience of time will end. Your world line will terminate. Does that mean time ends for you? In a sense, yes. Your subjective experience of time, your consciousness, flowing from moment to moment, will cease. But your world line will still exist in space-time. All the moments of your life will still be there, permanent structures in the block universe. And the light you emitted and reflected during your life, the photons that bounced off you and traveled into space, will continue traveling forever, carrying information about you to distant corners of the universe. Long after you're gone, photons that once reflected off your face will be reaching distant galaxies. Some alien civilization trillions of years from now could, in principle, gather those photons and reconstruct an image of you. You're not just a temporary pattern that vanishes. You're a permanent part of the universe's history, encoded in light, existing forever in spacetime. This is the ninth mind-blown moment. You are eternal. Not your consciousness, not your body, but your existence, your actual having existed, is a permanent fact about the universe that can never be erased. The photons carrying information about you will travel through space indefinitely. Some will be absorbed by matter. Some will redshift into oblivion as the universe expands. But some will keep going, forever, carrying the fact of your existence into the infinite future. You are written into the structure of space-time. You are part of the story of the universe. And that can never be undone. This, to me, is deeply meaningful. It suggests that every moment matters. Every interaction you have sends light into the world literally and metaphorically. The choices you make ripple outward through space-time, creating effects that propagate at light speed into the future. You can't change the past. Your past is fixed in space-time, but you can shape the future. Every decision you make determines which path your world line takes through space-time. And because of quantum uncertainty, the future isn't entirely determined. There are multiple possible futures, branching out from each present moment. Your choices help select which branch becomes real. In a very real sense, you are constantly creating the future with every decision, every action, every thought. And light mediates those decisions. Light enters your eyes, carrying information about the world. Your brain processes that information. You make choices based on it. Those choices create effects that propagate outward via light to other people and systems. You are a node in a vast network of causal connections, all mediated by light, traveling at the cosmic speed limit, creating the temporal structure that makes change and choice possible. This is what it means to exist in time. This is what it means to be alive. You're not just observing reality. You're participating in its unfolding. You're part of the process of the universe becoming, and light makes it possible. We're about 110 minutes in now. Let's talk about some of the cutting-edge research that's pushing our understanding of light and time even further. In 2015, scientists at the Weizmann Institute of Science in Israel performed an experiment that seemed impossible. They made light go backward in time. Well, not exactly. But they showed that under certain conditions, light's phase, the position in its wave cycle, could effectively move backward. By carefully controlling the quantum states of photons, they demonstrated that the arrow of time for electromagnetic waves isn't as rigid as we thought. This doesn't mean we can send information to the past. That would violate causality. But it shows that time's arrow is subtle and complex at the quantum level. Another fascinating development. In 2018, researchers led by Moti Friedman at Bar-Ilan University in Israel created time crystals, structures that repeat in time the way normal crystals repeat in space. These are patterns of laser pulses that maintain their structure while propagating through optical fiber. Time crystals are weird because they represent a new phase of matter that exists in the time dimension. They're not just static objects sitting in space. They're dynamic patterns in time itself. This research hints that time might have more structure than we realize. Just as space has geometry curves, dimensions, topology, time might have its own rich structure waiting to be discovered. And then there's quantum entanglement, which Einstein called spooky action at a distance. When two particles are entangled, measuring one instantly affects the other, no matter how far apart they are. This seems to violate the rule that nothing can travel faster than light. How can one particle know what happened to its partner instantaneously across vast distances? The answer is subtle. No information travels faster than light. The correlations between entangled particles were established when they were created together. Measuring one particle doesn't send a signal to the other. It just reveals a correlation that was already there. But here's what's weird. This correlation seems to exist outside of time. The two entangled particles are connected in a way that transcends spatial separation and temporal sequence. They're linked in the underlying quantum state of the universe. Physicist Asher Pears once said, "Quantum phenomena do not occur in a Hilbert space. They occur in a laboratory." His point was that our mathematical descriptions are models, and the real phenomena are deeper and stranger than the math. Entanglement suggests that reality has a layer beneath spacetime where separateness and sequence don't apply. Particles are connected in ways that ignore distance and time. This has led some physicists, like Leonard Susskind and Juan Maldacena, to propose that entanglement and spacetime geometry are related. In their A equals EPR conjecture, they suggest that entangled particles might be connected by tiny wormholes, shortcuts through spacetime. If true, this would mean that spacetime itself emerges from quantum entanglement. Space and time aren't fundamental. They're patterns in a deeper quantum structure. This is cutting-edge theoretical physics, and we don't know if it's true. But it's being actively researched right now, and it suggests that our understanding of time is still incomplete. Maybe time doesn't end if light stops. Maybe time is an illusion created by quantum entanglement, and light is just one manifestation of that deeper structure. Or maybe time is fundamental, and light is its messenger, and changing one would destroy the other. We don't know yet, but we're getting closer to understanding. Let's talk about practical implications. Not cosmic scale stuff, but things that affect you now. Because of light's finite speed and its connection to time, we live in a universe where simultaneity is relative. There's no universal now that applies everywhere. This seems abstract, but it has real effects. GPS satellites have to account for relativity. If we didn't correct for time dilation, your GPS would accumulate errors of about 10 kilometers per day. The system would be useless. Every time you use GPS to navigate, you're relying on our understanding of how light and time work together. The satellites send light-speed signals to your phone, and the system calculates your position based on the time delays. Let's talk about perception for a moment. Your experience of the world is mediated entirely by light. When you look at something, you're not seeing the thing itself. You're seeing light that bounced off it. And that light takes time to travel from the object to your eye. When you look at your hand, you're seeing it as it was about 1 nanosecond ago, because that's how long it takes light to travel from your hand to your eye at a typical distance. When you look at the moon, you're seeing it as it was 1.3 seconds ago. When you look at the sun, 8 minutes ago. The nearest star, 4.2 years ago. The Andromeda Galaxy, 2.5 million years ago. The most distant objects we can observe are galaxies so far away that their light has been traveling toward us for over 13 billion years. We're seeing them as they were when the universe was young, less than 1 billion years old. When you look at the night sky, you're looking back in time. You're seeing history written in light. And here's the thing, those distant galaxies don't exist in your present moment. You have no present moment in common with them. Because of relativity, simultaneity is relative. Your now is different from their now. In a very real sense, the universe doesn't all exist at the same time. Different parts of it are at different temporal locations, and we only know about them when their light reaches us. This means your perception is always of the past. You never perceive the present. You can't. Light takes time to reach you, and by the time it does, the moment it came from is gone. You live in a continuous stream of recent history, forever slightly out of sync with the universe around you. This is the 11th mind-blown moment. You have never seen the present. Everything you perceive is the past, delivered to you by light at its finite speed. The present is always slightly beyond your reach, separated from you by the time it takes light to arrive. Does this bother you? It shouldn't. It's beautiful. It means you're constantly receiving messages from the past. Every photon that enters your eye is a little time capsule, carrying information about a moment that has already happened. You're an archaeologist of the immediate past, reconstructing reality from ancient light that's nanoseconds to billions of years old. and your brain is incredibly good at this. It takes the scattered photons arriving from different directions and different times, and it weaves them into a coherent model of the world. It creates the illusion of a stable, present reality from a mosaic of past moments. Your consciousness stitches together the past into a perceived present, giving you the feeling of existing in the now, even though the now is forever inaccessible. This is what it means to be a conscious being in a relativistic universe. You're a pattern of matter that integrates information from the past to navigate toward the future, creating the subjective experience of being present, even though presence is an illusion. And light makes it all possible. Let's talk about the future of our understanding. Right now, physics has two great theories: general relativity and quantum mechanics. General relativity describes gravity, spacetime, and the large-scale structure of the universe. Quantum mechanics describes particles, forces, and the small-scale behavior of reality. Both theories are spectacularly successful. Both have been tested thousands of times and have never been proven wrong within their domains. But they are incompatible. They give different answers when you try to apply both to the same situation, like what happens at the singularity of a black hole or during the Big Bang. Physicists have been trying for decades to reconcile them into a theory of quantum gravity. String theory, loop quantum gravity, and other approaches have been proposed, but we don't yet have experimental evidence for any of them. When we finally do figure out quantum gravity, it will almost certainly change our understanding of time. Because time in general relativity is very different from time in quantum mechanics. In general relativity, time is part of the smooth, continuous fabric of spacetime. In quantum mechanics, time is an external parameter, not a dynamical variable. Quantum mechanics assumes time flows uniformly in the background, but we know that's not true. Time doesn't flow uniformly. It dilates, it curves, it behaves differently in different places. So quantum mechanics needs to be upgraded to account for this. Or general relativity needs to be quantized. Or both need to be replaced by something deeper. And when that happens, our understanding of what time is will change. Maybe time is emergent, like temperature, a large-scale pattern that emerges from underlying quantum degrees of freedom. Maybe time is discrete, coming in tiny indivisible units, like a Planck time, about y-43 seconds, the smallest meaningful interval. Maybe time doesn't exist at the most fundamental level. Maybe the universe, at its deepest level, is timeless, and time emerges only at larger scales, where gravity is weak and quantum effects average out. We don't know, but we're working on it. And when we figure it out, it might completely change how we understand the question: could time end if light stopped? Maybe the answer is that time and light aren't actually separate things. Maybe they're different aspects of a unified structure. Maybe changing one without the other is literally impossible. Not just practically, but logically, like asking what happens if a triangle has four sides. Or maybe time is more fundamental than light, or vice versa. Maybe one creates the other. These are open questions. The adventure of discovery continues. And you're alive during this adventure. You're living in an era where humanity is actively unraveling the deepest mysteries of reality, where we're sending probes to the edge of the solar system, building gravitational wave detectors to listen to colliding black holes, and constructing particle accelerators to recreate the conditions of the early universe. You're part of this. Your taxes fund this research. Your curiosity drives it. Your children or students might be the ones who make the next breakthrough. You're not separate from the scientific endeavor. You're part of it. You're part of the species trying to understand existence itself. And that's remarkable. Let's zoom back out to the biggest picture. The universe is 13.8 billion years old. It began in the Big Bang, a moment of infinite density and temperature, where the laws of physics as we know them break down. From that singularity, space-time expanded, cooled, and evolved. In the first microseconds, fundamental forces separated from a unified force. Quarks combined to form protons and neutrons. Electrons were captured by nuclei to form atoms. Gravity pulled atoms together to form stars. Stars fused hydrogen into heavier elements. They lived and died, scattering those elements into space. New generations of stars formed from the enriched gas. One such star was our Sun. Around it formed planets, including Earth. On Earth, chemistry became complex enough to become biology. Life emerged. Evolution proceeded. Consciousness arose. And now, 13.8 billion years after the Big Bang, the universe contains patterns of matter complex enough to contemplate their own existence, to ask where they came from, and to wonder where they're going. You are one of those patterns. And here's the truly staggering thing. The universe might be creating consciousness on purpose. No, I'm not suggesting intelligent design. I'm suggesting something stranger. If the fundamental constants of nature were even slightly different, complexity couldn't arise. Stars wouldn't form, or they'd burn out too quickly. Atoms wouldn't be stable. Chemistry wouldn't be rich enough to create life. But the constants are what they are, and complexity does arise. The universe is structured in such a way that it inevitably produces stars, planets, chemistry, life, and consciousness. The physicist Freeman Dyson once said, "The more I examine the universe and the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming." Now, he didn't mean a conscious universe. He meant that the laws of physics seem arranged to allow for our existence. Whether that's coincidence, necessity, or something else is an open question. But what's undeniable is this: you are here. You exist. You're conscious. You can ask questions about time and light and reality. And the fact that you can ask these questions is a consequence of the specific values of the fundamental constants, including the speed of light. If light traveled at a different speed, the universe would be different. Maybe radically different. Maybe too different for you to exist. So in a sense, you exist because light travels at exactly 299,792,458 meters per second. That number, that specific value, is part of what makes you possible. Change it, and you wouldn't be here to wonder about it. This is the 12th mind-blown moment. Your existence depends on the speed of light being exactly what it is. You are a consequence of that constant. And in asking whether time would end if light stopped, you're asking whether the condition for your own existence could cease. The answer is yes. If light stopped, time would end, and so would you, not just your body. The very possibility of patterns, like you existing, would vanish. But light won't stop. The speed of light is woven into the fabric of reality. It's as fundamental as existence itself. You're safe. Time will continue. Light will keep traveling. And you'll keep existing moment by moment, riding the wave of causality into your future. We're about 160 minutes in. Let's talk about meaning. Does any of this matter? Does understanding the relationship between light and time change anything about how you should live your life? I think it does. Understanding that time is relative teaches you that perspective matters. Your experience of time depends on your motion, your gravity, your reference frame. There's no universal, objective time. Similarly, your experience of life depends on your perspective. How fast you move through experiences, how deeply you engage with moments, how you frame your memories, all of this shapes your subjective experience of life's passage. Two people can live the same number of years, but experience vastly different amounts of life, depending on how intentionally they engage with their moments. Understanding that you live in the past, that everything you perceive has already happened, teaches you humility. You don't have perfect access to reality. You're always slightly out of sync, always reconstructing the world from delayed information. This should make you patient with yourself and others. We're all navigating based on incomplete, delayed information. We're all doing our best to understand a reality that's constantly slipping into the past before we can fully grasp it. Understanding that your world line is permanent, that your existence is written into space-time forever teaches you that your choices matter. Every decision you make is eternal. The consequences ripple outward at light speed, forever changing the universe. You can't take anything back. You can't erase the past. But you can choose what you add to the universe going forward. Understanding that light makes time possible teaches you gratitude. The fact that you can experience moments at all, that you can remember and plan and hope, is a consequence of the fundamental structure of reality being exactly what it is. You are profoundly lucky to exist. The universe had to be precisely tuned for you to be possible. And here you are, experiencing it. Every moment is a gift from the cosmos, delivered to you by light, traveling at the speed that makes time flow. Don't waste it. Let's talk about some final deep implications. If time is an emergent property, if it's not fundamental, but arises from deeper quantum processes, then time has a beginning and potentially an end at the level of the entire universe. Cosmologists believe time began at the Big Bang. Before that, there was no before. Time itself didn't exist. And if the universe eventually undergoes heat death, or big rip, or vacuum decay, time might end. Not just stop, but cease to be a meaningful concept. This means time is finite. It has boundaries. And we exist within those boundaries, in the middle of time's lifespan, during the era when the universe is complex and interesting. Billions of years in the past, the universe was too hot and dense for complexity. Trillions of years in the future, it will be too cold and sparse. We live in the sweet spot, the brief window when stars shine and planets form and life arises. You are living during the universe's prime. You are part of the most complex, interesting, vibrant era of cosmic history. And you're aware of it. You know what came before and what's coming after. You can appreciate your temporal position in the grand sweep of cosmic evolution. That's extraordinary. Most patterns of matter don't get to experience this. Most atoms just exist, moved by forces, without any awareness of their context. But you get to know. You get to understand. You get to marvel at the fact that you exist during this special time, in this special place, structured in this special way. You are the universe's way of appreciating itself. And when you look up at the night sky, when you see the stars and galaxies and cosmic expanse, you're not just seeing distant objects. You're seeing your relatives. You're made of the same stuff. You're part of the same story. The atoms in your body were forged in stellar cores. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it was created in nuclear fusion reactions inside stars that exploded billions of years ago. You are literally made of stardust. That's not poetry. That's physics. And the light from those distant stars, traveling across vast stretches of space and time, enters your eye and creates an experience in your consciousness. You perceive them. You appreciate them. You wonder about them. Light connects you to the cosmos, not just metaphorically, physically. Photons from distant galaxies literally interact with the molecules in your retina, causing chemical reactions, sending signals to your brain, creating thoughts. You are touching the universe, and it's touching you back through light. This is the 13th mind-blown moment. You are not separate from the universe. You are a part of it, connected to every other part by light, traveling through the space-time you all share. When you see a distant star, you and that star are interacting. You're part of the same system. And this interaction happens through time. The star emitted its light in the distant past. That light traveled through time and space. And now, in your present, it arrives and affects you. Past, present, and future are all connected by light. Causality flows through time, carried by photons, linking events across cosmic distances. You are a nexus point in this network of causal connections. The light arriving at you from countless sources integrates in your brain to create your experience of reality. And the light you emit both literally through thermal radiation and reflected light, and metaphorically through your actions and words, radiates outward, affecting other nexus points. You are a node in the universe's network of causality. You matter. You contribute. You participate. And because of this, your choices have cosmic significance. Not in a grand mythological sense, in a literal physical sense. Every action you take sends ripples through the causal network. Those ripples propagate at light speed. They affect other people, other systems, other parts of the universe. Those effects cause further effects, creating cascades of consequences that spread outward forever. You can't predict all the consequences of your actions. The causal network is too complex. But you can choose to send positive ripples or negative ones. You can choose to add beauty, kindness, truth, and compassion to the network. Or you can add ugliness, cruelty, lies, and indifference. The choice is yours. And it matters, because the ripples never stop. They echo through space-time forever. This is what it means to live ethically in a relativistic universe. You don't just affect the present. You affect the eternal structure of reality. Your choices are written into space-time, part of the permanent record of what happened. Make them count. We're approaching the end of our journey. Let's bring everything together. We started with a shocking question. Could time end if light stopped? And through our exploration, we've discovered that the answer is yes. If light stopped moving, if the speed of light went to zero, or if the electromagnetic field ceased to exist, or if the structure of space-time changed in ways that prevented light propagation, time would end, not freeze, not pause, bend. Causality would collapse. The concept of before and after would lose meaning. Reality would fragment into disconnected points with no relationship to each other. But we've also discovered something even more profound. Light won't stop. It can't stop. The speed of light is built into the fundamental structure of reality. It's the conversion factor between space and time, the cosmic speed limit, the framework of causality itself. Light is as fundamental as existence. Asking for light to stop is like asking for existence to stop existing. And because light won't stop, time will continue. Moments will keep flowing. Causes will lead to effects. The universe will evolve. And you? You'll keep experiencing your journey through space-time, moment by moment, perception by perception, choice by choice. You are a time-traveling conscious pattern of matter and energy, riding on light through the space-time you inhabit, participating in the universe's grand unfolding. You are made of stardust. You are powered by ancient sunlight. You are connected to the cosmos by light traveling at the speed that makes time possible. You exist because the fundamental constants of nature are exactly what they are. You experience time because you move slower than light. You perceive reality because light carries information to you from the past. And every choice you make adds to the permanent structure of space-time, sending ripples of causality into the eternal future. This is what it means to be you. This is what it means to exist. And now you know. You understand, at least to some degree, the deep physics underlying your existence. You've grasped the connection between light and time. You've contemplated the structure of reality itself. And this understanding should change you, not in some mystical way, but practically. You should live with more intention, knowing your choices matter eternally. You should appreciate each moment more, knowing it's a gift from the cosmic structure that makes experience possible. You should treat others with more compassion, knowing we're all conscious patterns trying to navigate a strange, relativistic universe with incomplete information. You should look at the sky with more wonder, knowing you're seeing ancient light from distant relatives, made of the same atoms as you. You should feel more connected to the cosmos, knowing you're not separate from it, but part of it. And you should feel empowered, knowing that you have the capacity to understand these profound truths, that your mind can grasp the deepest workings of reality. You are a pattern of matter that can comprehend the fundamental constants that made it possible. You are the universe knowing itself. And that is beautiful. That is meaningful. That is enough. So here's my final challenge to you. Go forward from this moment with the knowledge you've gained. Let it inform how you live. Let it inspire how you treat others. Let it deepen your appreciation for existence. Because time isn't ending. Light isn't stopping. And you have a whole future ahead of you, filled with moments waiting to be experienced, choices waiting to be made, and ripples waiting to be sent into the cosmic network. Make them beautiful. Make them kind. Make them true. Because they'll last forever, written in light, preserved in the eternal structure of space-time. You are a brief, brilliant pattern in the universe's long story. But you're also permanent, part of the unchanging record of what happened. Leave accordingly. Thank you for joining me on this journey through the deep physics of light and time. Thank you for staying curious, for asking questions, for wanting to understand. If this video changed how you see reality, leave a comment below. Tell me what surprised you most. Tell me what you're still wondering about. And subscribe, because there's so much more to explore. The universe is vast and strange and beautiful, and we've only scratched the surface. Until next time, keep looking up, keep asking why, keep marveling at the profound, improbable fact that you exist at all. Because you do exist. You're here. You're conscious. You're experiencing time, carried forward by light through the space-time you inhabit. And that is the greatest mystery of all.